In this video, we will look at side congruence rule. So what that says is, if there are two triangles of which the corresponding sides are of the same length, then these two triangles are congruent. So if there are two triangles A, B and C, there are two triangles, let's say this is triangle A, B, C, and this is triangle PQR, then the rule says that given AB is equal to PQ, so this side is equal to this side, BC is equal to QR, so this side is equal to this side, and CA is equal to RP, so this side is equal to this side in length, then these two triangles are congruent. So triangle ABC is congruent to triangle PQR. Now we will try and attempt a proof to this rule. So to do that, first of all, let us do a small construction. So let us take the triangle PQR. So this is the same triangle PQR, and from point Q, let us draw a line of length AB. Let's call this line GQ. So this line is of length AB, and this angle is of the same value as angle B here. Yeah. And let us now complete this triangle. So what we are saying with the triangle GQR is the side GQ is equal to the side AB, and angle GQR is equal to angle B of this triangle, of triangle ABC. Yeah. Also, we know that the side QR is equal to the side BC, which is right here. So you can see that the side BC is equal to side QR is something that is given to us. So if you take a closer look at these three, then it tells us through the side angle side rule, when applied to these two triangles, that is triangle GQR and triangle ABC, that these two are congruent. How? So side GQ is equal to AB, so GQ is equal to AB, angle GQR is equal to angle B, so angle GQR is equal to angle B, and QR is equal to BC, so QR is equal to BC. So by the side angle side rule, these two triangles are congruent. This is the first step in the proof. The next step will be about proving that this triangle and this triangle are congruent. So let's try and do that. So before that, let us join point P to point G. Through this small construction, what we will try and achieve is to prove that this angle and this angle, so these two angles are of equal value. So we will do it in again two steps. Step number one will be compare the triangle. Look at the triangle GRP, and in this triangle specifically look at sides GR and PR, or GR and RP. So we know that the side GR is equal to the side AC. It is through this congruence which we have just proved. The side GR is equal to the side AC. We also know that side AC or CA is equal to RP. So we can write it as GR is equal to AC, which is equal to the side PR. So what we have is these two sides are of equal length. So GR is of the same length as side PR. We know that in a triangle, the angles opposite to sides of equal length have equal value. So angles opposite to equal sides have equal value. So what that means is the angle RGP, that is this angle is equal to angle RPG, that is this angle, because these sides are of equal length. So angle RGP is equal to angle RPG. Good. Now similarly, following a very similar approach, we will prove that this angle, that is angle QPG, is equal to this angle, which is angle QGP. So to do that, let us again look at this triangle, which is triangle PQG. So if you look at triangle PQG and look at these two sides, so GQ and PQ. So side GQ and PQ, we have to prove that these two are of same length. So let us start from side GQ, and through this congruence which we proved earlier, we know that side GQ is equal to the side AB. So side GQ is equal to side AB, which in turn through this equality tells us that is equal to PQ. So we have proved that GQ is equal to PQ, and hence we can say that angles PGQ is equal to angle GPQ. Right? So now we have got these two equalities, and let us just simply add these two equalities. So to do that, let us do that. So angle RGP is equal to angle RPG plus angle PGQ is equal to angle GPQ. Sorry, this is plus. So we are adding. Yeah. So RGP plus PGQ, RGP PGQ is nothing but this angle G. This is angle G, and this is, if you look at it, is angle P. So RPG plus GPQ. GPQ is angle P. So this is angle P. So in now coming back, looking at these two triangles GRQ and PRQ, we have proved that these two angles are of same value. So G is equal to angle P, right? That is the first step. Second, we know that. So second, we have to look at the sides. Right? So we know that this side is equal to this side. So GQ is equal to PQ, which is here. And we know that GR is equal to PR. So GR is equal to PR, we have already proved it. So these three results, when we look at them together and apply, let me just for the ease of calculation write it here. Let me write all these three rules here together. So GR is of the same length as side PR, and GQ is of the same length as side PQ, and the angle here, angle between these sides, is also of same value. So this tells us very clearly by the side angle side rule that the triangle RGQ is equal to, or rather congruent to, the triangle RPQ. Yeah, so we have proved that this triangle and these triangles are both congruent, and we know that, you know, this triangle is congruent to this triangle. So hence, which we have proved here. Yeah, we have proved it here. So same. So if we join these two, so effectively we get triangle ABC is equal to, or rather congruent to triangle PQR, and this is what we set out to achieve.